Point 4, the tangent and velocity problems. Objective 1, the tangent problem. The student will understand the tangent problem and what it means with respect to the slope of the tangent line. The word tangent is derived from the Latin word tangens, which means touching or kissing. Thus, a tangent to a curve is a line that touches a curve. In other words, a tangent line should have the same direction as the curve at the point of contact. This is simple for a circle. We would simply follow Euclid and say that it's a line that has exactly one point of intersection with the circle. For another kind of curve like that, it doesn't work to say exactly one point of intersection. Figure 1b shows two lines L and T passing through the point P on a curve C. But we wouldn't want to think of the blue one as a tangent line. The line L intersects C only once, but it certainly does not look like what we think of as a tangent. The line T, on the other hand, does look like a tangent, but it intersects C twice. Find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. Okay, so we can all imagine this upward opening parabola, vertex at the origin in our minds, and then the point 1, 1 is obviously on that curve, and the tangent line, you know, we can kind of see it. What's its equation? We will be able to find an equation of the tangent line t as soon as we know its slope m. Okay, so we're to find an equation of a line. Okay, an equation of a line, y equals mx plus b, or y minus y1 equals mx minus x1, the point slope form. We have a point. If we can just get a slope m, then we'll have an equation of the line. The difficulty is that we know only one point P on T, whereas we need 2 points to compute the slope. But observe that we can compute an approximation to m, the slope of, in this case, the pink line, by choosing a point nearby, point Q, which is going to be the point x squared on the parabola, as in the figure, and computing the slope m, that is the slope of line PQ, of the secant line. A secant line, from the Latin word secans, meaning cutting, is a line that cuts or intersects a curve in more than one point. And so we're going to pick a point, some point, actually several points, such that x is not equal to 1, making q not equal to point P. And so the slope is going to be y2 minus y1 over x2 minus x1. Okay, that's the slope of the blue line. And okay, well, let's let x be 1.5. The square of that is 2.25, and so the slope of the blue line, y2 minus y1 over x2 minus x1, is going to be 2.25 minus 1 all over 1.5 minus 1, which is 1.25 over 0.5, which is going to be 2.5. So that slope of that blue line is 2.5. course, that's not the pink line. The tables in the margin show the values of the slope of line PQ for several values of x close to 1. Of course, we already, looked at this one. When x is 1.5, the slope is 2.5. But then we could do the same thing with a lot of other points, a lot of other x values. The closer q is to p, the closer x is to 1. And it appears from the table the closer that is the slope of line PQ is to 2. So x is getting closer and closer and closer and closer to 1, and these slopes are getting closer and closer and closer and closer to 2. Now that's for values of x greater than 1, and for values of x less than 1 and getting closer and closer and closer and closer to 1, the slopes again are becoming closer and closer and closer and closer to 2. Okay? So it looks like that slope of that pink line is going to be 2 just from the table. Okay, so this suggests that the slope of the tangent line t should be m equals 2. Of course, we were to find an equation of the tangent line to the parabola at that particular point. Of course, the equation is going to be different for different points. We say that the slope of the tangent line is the limit of the slopes of the secant lines, and we express this symbolically. Okay, so we were getting a limit because x was getting closer and closer and closer and closer to 1, and so what's the limit? Okay, well, we write the limit as point Q approaches point P of the slope of line PQ equals m. Okay, that's the slope of the pink line. And the limit as x approaches 1 of, well, that's the slope formula. Okay, y2 minus y1 over x2 minus x1 equals 2. Okay, the limit of those slopes is 2. Okay, so m equals 2, and now we can get an equation. Assuming that the slope of the tangent line is indeed 2, we haven't really proven that, we just are kind of arguing from the table. We use the point slope form. Okay, y minus y1 equals mx minus x1. We use the point slope form of the equation of the line to write the equation of the tangent line through the point 1, 1. Okay, so there's an x1, y1. And here's our y minus y1 equals mx minus x1. Okay, and that would be a good answer. Okay, that's a perfectly good answer. That's an equation of the tangent line. Okay, assuming that we got the slope right, which is 2. We're pretty, sure of that. We could write this equation in slope-intercept form. We would distribute the 2. Y minus 1 equals 2x minus 2. Then add 1 to both sides, and y equals 2x minus 1. So either way, we have an equation, whatever form a person would want, to the tangent line. Figure 3 illustrates the limiting process that occurs in this example. Okay, so we're going to let Q approach point P, and so Q is getting closer to P, Q is getting closer to P from the right, or maybe from the left. Maybe Q is on the other side of P, and Q is going to get closer and closer and closer to P. Okay? Now, what I want you to notice is how the blue line is going to approach the pink line. Okay? As Q gets closer to P, the blue line approaches the pink line. So let's run this again. Now watch the blue line as the blue line approaching the pink line. And so it's getting closer and closer to the pink line. And with Q on the other side, again, the blue line is going to approach the pink line. Approaching, getting closer, blue line, approaching the pink line. Okay, so that's the tangent problem, and for millennia, mathematicians have been able to do what we just did, and we, are confident in the slope of 2 for this pink line, and that's been a way to approximate the slope and of the pink line. And if you get the slope, you can get an equation of the line. But calculus will be used to get actually the slope and equation.